We're here at British Steel's site in Scunthorpe, where we're demonstrating our field tests of laser-clad coatings for rail life extension and for repair. At the University of Sheffield, we've been doing research on laser-clad coatings for rails for over 15 years now. We started in small-scale tests and we've moved up to our field tests. The idea behind the laser cladding is that it will help to enhance the lifespan of rails, reducing costly repairs or replacements.
So laser cladding is a process by which one metal can be added to another using laser beam as a heat source. So unlike other welding processes, it's very controllable. We can put material exactly where it's required. We can take a standard substrate and we can add many different metals to that substrate using laser cladding to enhance its wear performance, corrosion performance and life extension. So back over 10 years ago, we thought that laser cladding could be of advantage in the rail industry and the rail sector. We know for sure that rail suffers from wear on high radius curves, points, crossings, switches and the likes. So we thought the ability for us to apply a different material onto the rail to enhance that wear life at that point could prove invaluable to the industry. And over the period of 10 years, we've enhanced the process. Sheffield University have done a lot of testing and now we're at a stage where we've got the track in situ so that real life testing can be done.
For life extension, our small-scale test led to us using martensitic stainless steel or stellite 6. These materials are really hard wearing and really reduce wear within the rails. They also help to protect against rolling contact fatigue. So the initial field tests that we have here were constructed of 2 strings of 6-metre long rail. These consist of individual 1-metre lengths of either premium grade rail, standard grade rail, or the MSS coating and the stellite 6 coating. The results show that the wear is really reduced on the clad layers compared to the standard and premium rail that we have installed here. One of the key things that we've discovered throughout the research is the importance of optimising the laser parameters to create a good quality clad layer which is free from porosity and has a really strong bond between the substrate rail and the clad coating itself. Once we were confident with the life extension method of laser clad coatings, we started to look at it as a repair method. Again, we tested the repair method through small scale testing, through full scale testing, and now we have a second field test out here which sees a 9-metre length of R260 rail that has been filled at a 200mm length with a R260 powder at a 3mm depth. This second field test has been in place since August 2025.
Hi there, I'm Naomi Cortine and I work in the British Steel Rail R&D team. And I'm stood here today at our part of our internal track network. I'm by the Doyle's Lane coke ovens and we use this part of the track, which is part of our route in and out of site, as a little bit of a test track. British Steel are always interested in what happens with our rail, both helping support our customers and understanding the effects on the rail itself. We've been involved in this project for at least my 9 years at the company, and I think a bit before that, so order of 10 years. It's nice to see it coming closer to fruition, performing so well in the track. Other than that though, all the exciting work's been done by the wonderful people over at the University of Sheffield, who we're very happy to be working with.
Potential applications for the life extension method would be areas such as high curvature rails or IBJs. This is due to that reduction in plastic shear strain, which would help to reduce lipping in these areas.
So the next steps for this process are for us to gain approvals so that we can move this development further into real scenarios. We'll be looking for approvals from the likes of Network Rail, and we'll also be looking potentially for partners so that we can install this equipment on trains so that repairs and life extension can be done in situ on live track.
We want to ensure that it's maintainable once the clad coatings are in. We want to look at the cost benefit analysis. We would like to start to work towards an in situ repair method and also look at it for refurbishments. So there are lots of things that we would really appreciate some support to make this a real viable process for the network.